Hey guys, I'm Dan with Sequence Engineering, and today we're going to show you how to build a 12-volt, 3,000-watt system. Here at Sequence Engineering, we are purpose-built to provide you with the equipment you need for any off-grid project. Okay team, to get started today, we are going to do a very quick overview of this stuff that I have on the table. I know that it probably looks like a lot of stuff. It probably looks like, a bit of a mess. But when you go to start your project on your van or your RV or in your cabin, you need to lay the equipment out that you have, and you need to understand everything that you are about to accomplish. Okay, so first, what we have on this table is we have an Orion XS. This is a 12-12-50. This will serve as our alternator charger in the example that we're going to put together today. All right, so DC to DC charger. We have a small fuse block here, which is used for some of our communication cables coming off our BMS. We have a fan, we have a light. Those things are just going to be used for some programming that we do later. We have a Touch 70. Okay, this is what you're actually going to use to control most of the components in your system after they're installed and programmed. It's also going to show you what's happening across the entire system. We have a master cutoff switch. This is the BEP 770. Very common, very popular switch. We also have a small MPPT. You're probably going to be running a slightly larger solar charger in your system. This is the 120. Works great for this example, but you'll probably be running something a little bit bigger than that. We also have an AC to DC distribution box over here, which is going to be a very simplified version of something that you're going to install. This device here is just a small, cheap PV breaker that we like to use for demonstration purposes. And over here we have a Victron lithium 12-volt, 100 amp hour battery. This is the smart battery. They also sell the NG version of this battery now, but this battery does have the communication cables coming from here and is controlled by an external BMS, which we are going to run through. Over here we have the Serbo GX. This is the OG version of the Serbo GX. They do have a new model of this now called the Mark II, but the overall function of this and how it will work in this example will be very helpful. In here we have the Lynx Smart BMS connected to a Lynx distributor. You guys will notice that we've already gone ahead and connected these two devices together. We'll cover a little bit of that later once we pop these covers off. In addition to those two components, we also have a small battery protect. This is the 12-24-65, so that guy's good for 65 amps. We have a small DC distribution block. This is actually the Blue Sea 5025. Most of you guys will probably run a slightly larger fuse block than this, but this is a great example for this display. This is the 6-slot version. They also sell a 12-slot version called the 5026. And over here we have a RUVI tag, right? For those of you who don't know what a RUVI tag is, this is simply a temp sensor that will communicate with other devices via Bluetooth. You can see the temperature data that you get from this device on your phone, or you can actually see it on your Serbo. It is very handy and it has native integration with the Serbo so that you can see it on Bluetooth very easily. It's super easy to program, and we use a ton of these in our systems, right? It's very helpful to know the temperature in different areas of your coach. In addition to this device, they also sell one that has a small white circle right here, which is actually a membrane, so that you could also see humidity if you want to do that. And over here we have a small copper bus bar that we actually use to connect the master switch to our positive terminal on our smart BMS. You may also use this to connect your master switch to your Lynx distributor if you're not using a Victron battery or some other setup. But we'll just show you a quick overview of what this looks like. We actually sell these on our website. This is a piece of copper that you will notice is tinned. Okay, so we do have these tin plated so that they will not corrode over time, and they are designed to work with either an M8 or an M10 Lynx distributor. Be careful when you buy them because they are differentiated by the M8 or the M10. This one is the M8 version, and it does connect right here. You'll see more about that shortly. And there's one last component that I haven't shown you guys yet that's not on this table. It is actually our inverter. Down here I have a Multiplus 2 3000 volt amp inverter, and I'm actually going to go ahead and hang this on the mount, which I've already pre-mounted onto our display board. Okay, let's get started. The first thing we're going to do is we're going to cover what it will take to hook up our battery. All right, and so I'm actually going to show you guys what it means to set up these M8 cables coming out the front of your Victron Smart battery. On this particular version of this battery, you'll notice that there's no orange ring. On new versions of this battery, the NG battery, you will see a small orange ring just to show you that they are the NG battery. But what you'll see is you have a male and a female version of these two cords. What these cords actually do is they actually feed data to our BMS. They feed high voltage, low voltage, and temperature data to our BMS so that this device can then tell other devices in the system what to do and when. And in order to hook up to these, you most likely need an extension. So I actually have an extension cord here. So you can buy these M8 cables to allow you to move your battery further away from your BMS if you need to. But I'm simply going to connect the male version to the female version here, okay, as you can see. And be careful when you do this, because I have successfully cross-threaded one of these before, and it was not a fun situation. So be careful when you do this. They are relatively easy to do, but you do need to get them lined up and be diligent when you do it. Now I'm going to take this female end and I'm going to plug it into the male end here, like so, and then you simply screw these two together. Okay, and once you have that done, you are now ready to position your battery where you need it. So I'm just going to move this battery down here and we'll come back to it when we need to hook it up to our BMS shortly. The next thing that I like to do is I do like to start by positioning my Multiplus, which we have already done, right? The Multiplus is a device that takes up a lot of space, and it also requires a little bit of room for your cables to come out the bottom. So it's helpful to position your battery, your Multiplus, and the other large devices in your system, like your Lynx distributor, as your first order of business. So what I want to do is I now want to show you guys where this is going to be positioned in the system. This is more or less the heart of the system. And so I'm going to pop these covers off, and then we are actually going to mount these two devices right here. Okay, so in order to pop these covers off, all you need is a Phillips head screwdriver. So you're going to take your Phillips head screwdriver and you're going to simply loosen the screws. These screws in these covers are actually captured, so you cannot take them all the way out. So do not waste your time trying. Simply loosen them all the way up. Okay, that's one. We're going to pop that cover off, set it here, and then we're going to pop this cover off. And we're going to set it here. What you're going to see inside of this device is, one, you're going to see that it has fused locations for all of your positive hookups. So because we've used this device so many times in different training classes, we actually have some fuses pre-positioned here already. But typically when you take this cover off, you're just going to see nuts and bolts and no fuses. All right, so from here over is your M8 Lynx distributor. And from here over, you have your smart BMS. The smart BMS is actually 3 devices in one. This is your shunt. This is your contactor or on-off switch if you choose to use it that way. There's a large contactor in here that will either allow or not allow power to go from here to here, okay, based on what the BMS sees in other components in the system. And this is also your BMS, right? And we know that BMS stands for Battery Management System. Now, what you also need to know is how you would actually mount this device. Okay, so I'm going to point out the mounting holes for you. What you'll see is you have a mounting hole over here. You have a mounting hole down here, one down here, one in there, one in there, and one in there. Now, you would think that they would be in line, but they are not. And so you need to be diligent about how you lay this device out in order to mount it efficiently. Most of you guys are going to be mounting this to some type of wood substrate, although Victron recommends that you mount to something that is non-flammable. We know that most customers do that anyway. So just be sure that you get a screw that will actually fit inside of that recess, and that will also give you enough mounting power to, hold this to the wall securely in your application. In this situation, we're actually going to be using these screws here that we have already pre-positioned. And so I'm just going to go ahead and I'm going to mount this to our display board. So I'm going to drop this screw right in here like so, and then I'm going to go up here and see if I can get this guy started. Okay, we've got one in there, nice and snug. Now I'm going to go over here and see if I can get one of these lined up. A fun thing to also consider is that when you are building one of these systems, a lot of times it's actually easier to do it on a flat surface than to try to do it in a vertical fashion like I'm doing right now. So if you do not have pre-positioned holes and everything already lined up, you may find it easier to try and build it on some type of flat back plane before you mount it. But every application is different, and you'll find the solution that works for you. Okay, now that that's hanging there, I'm going to put 2 more screws in it just to secure it for our demonstration. Now that we have our smart BMS and our links distributor secured to our board, I'm going to show you guys how it's connected. When you receive these 2 devices, they will actually be separate. You will pull off the cover, and what you'll find is you'll have an M8 nut here and an M8 nut here with a washer and a lock washer. You will simply remove those, connect your links distributor, and then torque these back to their required specification. Now, that is the first time that I've mentioned a torque spec in this demonstration, and you're probably asking yourself, where do I go to find that torque spec? So if you want, you can make your life super easy, and you can jump on the Sequence Engineering website, seqengineering.com. You can go to the resources section of our website, and you will find manuals on this particular training demonstration that will actually cover the torque specs, and will also cover the entire step-by-step how to build this system in this manual. Okay, so this goes from what equipment we're going to mount, all right? It goes through all your torque specs, and it goes through programming of each device. So step-by-step manual available in the resource section of seqengineering.com. So I flipped over here to page number 5, and it actually calls out the torque specs for each of the devices that we are going to install today. Now that we know the torque specs, you can simply find, all right, which one of these am I doing? Links distributor and smart BMS. It says that the bus bar should be torqued at 14 Newton meters, the M8 bolts 14 Newton meters, and then the plastic bridge nuts, which are actually the nuts behind this location here, those are actually torqued slightly lower at 10 Newton meters. So we know that those 2 bolts should be torqued at 14 Newton meters. Okay, and what you'll find is that a lot of the bolts that are in a similar size range, like M8 bolts, are typically torqued to a very similar setting. I recommend that you check each one, but it does help to know that they're relatively close. Okay, now that we've covered the torque specs and where you could find them, I'm going to go back over here to our links distributor and this mysterious gray cable. This mysterious gray cable is actually an RJ12 connection, and it goes between your links distributor and your smart BMS. We get a lot of questions about what this cable is and what it actually does. In this particular application, if you're using a smart BMS, all right, this device, it will actually read resistance from here to here and tell you if you have a blown fuse on this device. So if I pull up this device on Victron Connect on my phone, it will tell me if all of these fuses are in good shape or they're not. Now, if you are not using a Link Smart BMS and you plug this RJ12 into, let's just say, like a 5-volt conversion, something that's just going to supply 5 volts to this device, it will make the lights light up. So if you just really want to see those lights light up on your links distributor, that is how you would do it. But beyond that, it doesn't give you any other functionality. It's not actually going to tell you if your fuses are blown unless you have it paired with a smart BMS. So that's all that power cord is going to do unless you have it paired to the smart BMS. If it is paired to the smart BMS, it will tell you that your fuses are blown. Okay, now that we have the heart of our system positioned, right, we have our battery, we have our Multiplus, and we have our links distributor all in position, the next thing I'm going to do is I'm actually going to mount all of these other components to the board. Now, as you go to mount these components, you will notice that some of them have, different mounting features, right? Your MPPT has these metal slots. Your DC to DC charger just has these small blind holes. So you do want to prepare a various number of different types of mounting solutions, right? So you might need a different size screw for this than you will for this, and some of the components are heavier than others, right? So just be cognizant of that and make sure that you only have to go to Lowe's once, right? So plan all that out before you go to this stage, and it will save you a ton of time. So here we go. Okay, now that we have everything mounted in position, we are now ready to actually start hooking up all these components so that they will work together. One thing that I want to highlight when we get to this point is that what I just did in a very short period of time on this video is going to take you quite a bit more time, right? The layout and the design of how you position all of this stuff in your application is a timely process and isn't something that you should take lightly. So just take careful consideration of how you want these things to work and where you want them to be positioned in your build, and get all of this done, and then you'll be ready to move on to the step that we're at now. The first thing that we're going to do is we're actually going to connect our master disconnect here, our 770EZ switch, to our Link Smart BMS. And we are going to do that with our tinned copper bus bar that we have here. I'm actually going to take this copper bus bar, I'm going to position it here, and then what I'm going to do is I'm actually going to connect it to the switch first. And what you'll find when you do this is that the spacer that is provided with this copper bus bar here will actually allow this to be positioned at the perfect height so that it lines up with your Smart BMS, okay? So you'll see that those two holes are now lined up and ready to be assembled. Okay, now that we have our copper bus bar positioned, I'm going to give you guys a very quick overview of everything that comes in this connector kit. So you would receive this tinned copper bus bar, this spacer that positions your switch, and you would receive this hardware. This is all stainless hardware with a black dacrymet finish on it so that it will not corrode. What you get is a bolt, 2 washers, 1 lock washer, and a nut. And they simply are installed like so. So you would position that there, and then you would take your washer, lock washer, and nut, and you would position them behind it. And once you have it in position, you will simply take your wrench and your ratchet, and you will snug this up before you grab your torque wrench. Okay, now that I have that snugged up, we're going to grab our torque wrench and we are going to torque this according to the specifications in our resource here. So I'm going to grab my torque wrench, I'm going to set it to the appropriate torque, which according to my manual is 14 Newton meters. And we are going to torque it to spec. So here we go. Click, everybody's happy. Okay, now that we have this bolt torqued, we are now going to torque this bolt. You will notice that it is a different size, so we are going to move over to a 17 millimeter socket that you see here, and we are going to torque that bolt. That torque setting is slightly higher. I'm going to set my wrench to the correct torque spec for that bolt, which I do believe is 15 Newton meters. And we are going to torque this bolt. Okay, that bolt is now torqued, and we are going to move on to our next component. Okay, now we're actually going to install the wires into this device and route them down to our Lynx distributor. What you'll see is that I have 2 pre-made 10 gauge wires. You'll also notice that each wire has a crimped ferrule on it. We get a lot of questions from customers about whether or not it's necessary to use a ferrule, and the answer to that question is absolutely. Right, so this ferrule is actually going to prevent stray wires from contacting some other component in the system and causing a fault. I've seen many systems have a fault because of a lack of use of ferrules. Okay, so yes, do use ferrules. And if you are wondering what you need to crimp a ferrule, it's actually a device like this. You can grab a ferrule crimper on Amazon for 20, 25 bucks. So grab a tool, grab a pack of ferrules. It's worth the expense, and it will save you a lot of heartache in the future. Now, the first wire we're going to install is our ground or negative cable on the device. And in order to do that, you're simply going to ensure that this center terminal is backed out all the way, but not completely. And then you are simply going to take your wire, insert it in like so, and then you're going to come back and snug this terminal up. Okay, we've got that snugged up. Then I'm going to tuck this wire down into our wire tray, and I'm going to route it over here like this and leave it kind of loose like this for now. So now we have this wire positioned to where it is going to ultimately go. Next thing I'm going to do is I'm going to install my positive wire. It is also a 10 gauge wire for this demonstration, and I'm going to insert it into this terminal, and I'm going to snug that up. Okay, that's now snug. We're going to spend a second routing that wire. And while I route this wire, I want you guys to take note of the fact that we are using wire tray in this demonstration. What you'll find is that using wire tray is going to dramatically improve the overall look of your system. It's going to clean it up quite a bit. So now that I have these wires positioned to where they are ultimately going to go, I'm going to position them on the fused location where they're going to live. Now, this fuse here is a 60 amp fuse, okay? You need to ensure that you are putting these in the correct location where the fuse is supposed to be for that device. And all I'm going to do is I'm going to take this wire, position it there over that terminal, and then I'm going to grab my mounting hardware, and we are going to snug that up. Okay, washer first. Never ever put a washer between the lug and where the bus bar is positioned. Washer first, then lock washer, and then your M8 nut. Okay, you can snug that up by hand. And then you'll actually want to go ahead and finish torquing that connection to spec, because what you'll find is that your positive wire coming over top of that will actually prevent you from accessing that nut. The negative is complete, and we are now going to jump over to the positive connection. Okay, we're going to take this cable and we are going to route it up to our positive connection, and then we are going to position it over the fuse, and we're actually going to torque this nut and this nut to the correct specification. So, washer, lock washer, nut, snug both of those up by hand, grab your torque wrench, and torque to spec. Now, before I torque this particular nut in this application, you'll notice this red wire, okay? This red wire is actually sending positive power to this board behind it. And when you receive this unit, you'll notice that this is actually already installed on that stud. Now, future designs of the Lynx distributor, they've actually moved this over to its own separate stud. But if you do receive this Lynx distributor, you need to remove that first, and then put your fuse on and position this over the fuse. Okay, so you're going to have bus bar, fuse, this red wire, then washer, then lock washer, then your nut. All right, both of those connections are now made, and we're going to move on to the other connections that we are going to demonstrate on our Orion XS. So on this device, you will see that we have several open ports. We have the in that we already talked about, right? That is going to be running to our alternator connection. Then we have a remote port here that says L and H, and we have a VE direct port. Now, the remote port, any remote port on any Victron device is going to allow you to remotely activate or deactivate this device. You can literally think about it as if it is a switch that either turns it on or off. If I supply voltage to the high side of this remote, it's going to allow this device to operate. So I can control this device in two ways because it has both a VE direct and a remote port. So for the sake of demonstration, I'm actually going to wire this 16 gauge communication cable to the high side of this remote port. And where that's going to go is we are actually going to route it down here to our BMS allow to charge port. And what that's going to do is it's actually going to allow our BMS to turn this device on or off simply by either supplying voltage to the high side of this remote port or not. The other ways that this remote port works is you can also simply loop that. So you can actually, when you receive it, it'll actually have a black cable. And what that's going to do is it's actually just going to force the device to be on no matter what. And so unless you remove that cable, it's simply going to sit there and it's going to tell the device to work based on the parameters that you give it, like the programming that you supply to it. And so we're going to install this cable, and after I do that, I'm going to come back and I'm going to explain how this VE direct port works in this particular demonstration. So here we go. So you can actually, if it's easier, you can actually take this port out. You can wire it here, okay, like so. So make sure that you have that backed out before you start, and then tighten up your connection. Okay. That's good and tight. And then you could actually reinsert it. And then you can route this cable down however you'd like. We do not have enough length to go all the way around, so we're actually going to route it behind our main hookup here, like this, down to our cable tray. And we are simply going to leave it there until such time as we get to wiring our BMS. Okay, so we now have that communication cable wired, and we're going to move over to this VE direct port. This VE direct port is used to also control this device, and it is also going to give us visibility of what this device is doing ultimately on our Touch 70 via our servo. So we're going to connect a VE direct cable from here to here, our VE direct port on the top of our servo. Now, when you have this cable connected and there is a BMS also connected to your servo is smart enough to know that the BMS is in control of everything else in the system. So if you have a device that doesn't have a remote port, but it does have a VE direct port, and you are using a Victron BMS like so, then the BMS is going to tell the servo what's happening, and then the servo is going to tell this device when to operate and when not to operate, okay? An example of that would be, let's say it's really cold outside and your batteries are sending information to your BMS that says, hey, I'm really cold. The BMS, it doesn't want your batteries to charge in that condition, and so your BMS is going to then send some communication over here to our friend, the servo, and it's going to say, servo, it's too cold to charge anything. Please tell any device that you're connected to not to charge, okay? And so that's when the servo is actually going to tell our charger not to charge, okay? So we're gonna go ahead and we're gonna route this cable. And we're gonna come up out of our wire tray over to one of the 3 VE direct ports on the top of our servo, and we are going to insert that cable. So now this device is now being told what to do by our servo, or the BMS can directly tell the charger to turn off via the ATC port, allow to charge port on the bottom of the BMS. Now, before I put this cover back on, I do want to show you guys that we also need to torque these bolts here. And in order to do that, you may have to acquire yet another tool. This is a screwdriver torque wrench, right? I don't have a better way to describe it other than that, but it does actually allow you to set torque measurements by simply pulling this and moving it in and out. This particular version came out of one of our training kits. It is a very cheap variety of this type of tool. You could find this on Amazon for not a ton of money. But what we'll do, we'll reference our torque spec over here. We will set our torque wrench, okay? We're gonna crank that on up to where it should be. And then we're gonna come over here and it's gonna work exactly like any other torque wrench you've ever used. You are going to apply torque to the screw like you would any other normal screwdriver. And then it's going to click when it has reached torque. Okay, click. We're going to do the ground. Okay, and now we know those two are torqued to their correct specification. Now that we've got that done, we are actually going to apply this cover, and then we'll be ready to move on to our next device. Okay, now that we've finished wiring our DC to DC charger, our Orion XS, we're actually going to move on to our MPPT. And what we're going to do here is we're actually going to run wires from our PV disconnect over to our charger, and we're going to connect them to the PV port. PV stands for photovoltaic, in case you're wondering, and those are actually going to be 10 gauge wires on that input. So we're going to do that real quick. So we're going to start with our negative cable on the bottom side of this switch, and what you would have coming in the top side of the switch is actually your PV cables coming in from outside or through the wall or through the through the roof of your van, right? Your PV cables are going to enter here, and what the switch is going to do is it's actually going to serve as an on-off switch. It's also going to give you circuit protection. So this will trip at 16 amps. This is a very cheap Amazon version of a PV disconnect. You may decide that you want to go with a little higher end device for this application, but we have used these in several applications that have worked quite well. So if you need like some type of UL cert or some other cert, be sure you include that in your design. So negative cable goes in the bottom. We're going to snug that up. Now, as you feed 10 gauge cables into the bottom of one of these smaller MPPTs, you will notice that the max wire size for this device is 10 gauge. And it can sometimes be a bit of a challenge to get that in there, but don't force it, don't break anything, be patient, and it will work. Okay, negative PV, otherwise known as solar, is complete. We're now going to do our positive, okay? We're going to put the positive in the bottom of our PV disconnect. And we're going to get that snugged up. Okay, that's ready. Drop this wire down into our wire tray and come back up here into our charge controller. Okay, now that we have our PV cables ran, we have our negative and our positive going to our negative and our positive. You're probably asking yourself, like, Dan, do I really need to torque those connections right here? And the answer is yes. So you will go back to your torque screwdriver and you will torque each one of these. Okay, and then you'll reset it for that spec, and you will also torque those two connections, and then that will be complete. And the next thing that we need to do is we actually need to run our cables from the battery connection down to our Links distributor. So the battery plus and minus is actually the connection that's actually going to feed that power to our DC bus bars. And so we're going to run those two cables now. We're going to do positive first. And we're going to route this cable down here and let it rest for a minute while we hook up our negative cable. All right, and we remember that we want to route our negative cable first so that we don't block our other connection. And in this particular scenario, we are going to route this cable over to our 40 amp fuse. And if you're wondering how we decide where to position which connection goes where, there is really no rhyme or reason as to which one of these locations that you pick. The only time where it really benefits you to move from one location to the other is if you're using really big wire, like 4-aught or 2-aught wire, and it makes more sense to be down here or down here. Later, we're going to run some 4-aught wire over to our Multiplus, and so you'll see that it makes a little easier for us, maybe slightly easier to run 4-aught off of this position than any of the others. But outside of that, you can choose any location that you want as long as you're connecting it to the proper size fuse. So this one is actually going to go down here. You're probably asking yourself, Dan, why are you using a 40 amp fuse on a 20 amp charger? And typically you would try to use a fuse size that is slightly closer to the charger's actual output, rated output, right? So this charger's rated output is 20 amps and this fuse is 40 amps. Normally what you want to do is try to get somewhere in the 125% range, and then you actually size your wire to match that 125%. In this application, for this short of a run and for training purposes, we decided to use a 40 amp fuse because it's pretty challenging to find mega fuses smaller than that. We're actually going to torque this negative connection. Okay, that's all set. And then we're going to route our positive cable. Now we are snugging up our positive connection, and we're going to go ahead and torque both the top and the bottom. And while I torque this connection, I will give you guys a brief note on wire size. If you do not know what size wire you need, an incredibly helpful resource is the Blue Sea Circuit Wizard. The Blue Sea Circuit Wizard will allow you to input your voltage, your length of run, and your estimated current, right? The number of amps that you are planning to draw over that run of wire. And you will input those variables, and then it will actually tell you what size wire it recommends for that application. And it is incredibly beneficial to size your wire correctly, not only for safety, but also for functionality. We will actually cover sizing wire in a future video. All right, now that is all that we are going to attach to our MPPT. If you're asking yourself, Dan, why are you not using the load port? The reason we're not using the load port is because you would use that in a standalone system where you might only have solar and a battery and then like a small DC bus bar. You can actually use that to power a small DC bus bar and control it with this device. Pretty useful feature. Definitely encourage you guys to learn more about how that feature would work by either reading that manual or checking out all the different ways that guy can actually work. Now, this device, how do you guys think it's being controlled in this system? Right over here, we said that this device could either be controlled by the remote port or the VE direct port. If you look at the face of this device, you don't see where it has remote or VE direct label, but super secret, there's actually a VE direct port on this device right here. So this device is going to get connected to our servo just like our Orion XS. And our BMS is going to talk to our servo, and our servo is going to tell this device what to do and when, specifically when to charge and when not to charge our battery bank. All right, so going to hook up a VE direct cable real quick and get that routed. All right, now we have our VE direct cable routed, and it is now connected to our MPPT and our servo, and so now the MPPT will be getting direction from the servo. Earlier I mentioned to you guys that the Links distributor is the heart of the system, right? It is the central location where everything is connected. If that's the heart, the servo is your brain, okay? So the brain is actually telling everything else what to do and when. All right, now we're going to take a look at how we would wire our battery protect. So the battery protect is a device that you can use in one of two ways. So a very quick note on simply how this device is used in other systems and specifically how it's used in this system. So you can actually use this device as a remotely controlled switch by either sending voltage to the high side of this switch or not. In addition to that, you can also program this Bluetooth capable device to either turn on or off based on the voltage that it sees. All right, so the name of it is Battery Protect, and the way that this device is typically used in that fashion is that you would simply set it to turn off at low voltage, right? So let's say that you did not want to deplete an AGM battery beyond 50% or something like that. You would simply set this up to turn off at a specific voltage in that range, right? So pretty cool device, and in this setup, we're actually going to use it to be controlled by our BMS. Okay, the BMS has the ability to control this device using the remote port by sending voltage or not sending voltage to the high side coming off of the ATD port here. So the ATD port stands for allow to discharge. And so we're going to run a communication wire from here down to the H on this remote switch. And that is going to tell this to turn on or off, which is ultimately going to control all of the loads that are connected to this DC bus bar. So if the BMS doesn't want any more power coming out of the batteries, then it's going to tell this guy, hey, stop allowing power to flow through to the DC bus bar. And so it's going to switch that device off. Now, these devices come in 3 different sizes, okay? And they actually just added a 4th one in the 48 volt category. But this particular device comes in a 12, and a 12, 24, 65, a 12, 24, 100, and a 12, 24, 220. What that means is that it will work with either 12 or 24 volts, and it will allow either 65 amps to flow through it before it will destroy itself, 100 amps, or 220 amps. So you need to size that device to the amount of current that you're expecting to pass through it. With that being said, you also need to note that it has an in and an out. So this terminal over here is in, this terminal over here is out. It is clearly labeled on the face of the unit. You need to position this device in your system such that the current is going to flow in one direction. Now, here we are expecting the current to go from Links distributor down the wire to the in terminal over to the out to our DC loads downstream. Okay, so be sure that you position that device correctly. If it's being used on a charger or in some other application, you may have to flip the in and the out based on the current flow. Okay, so we're going to go ahead and we're going to get that guy wired up and show you ultimately how it all comes together. So wires are here, and we have a positive connection that's going to be going from our Links distributor to our in port. And then we also have a positive wire that is going to feed our BlueC 5025 bus bar. So we are going to go ahead and loosely connect these, and then we will come back and torque them to spec. And now we are going to hook up our positive connection from our Links distributor down to our Battery Protect, okay, the in port on the Battery Protect. So I'm going to connect this here, washer, lock washer nut, snug that up. We're going to torque the top and the bottom. You'll notice that sometimes when you torque these things, the wire wants to move one direction. So sometimes it's helpful to hold it in position while you get it tight. Okay, then we're going to move up here to the top. I like to put a little bit of pressure on my fuse itself so that we're not putting too much torque on the fuse body. So I'm going to do this. Okay, now our positive and our negative connections are complete, and we will route this down to our battery protect. As I do this, you will notice that the cable is too short and that this is intended to be flipped the other direction. So we're going to go ahead and do that now. We're actually going to flip our device around. Okay, here we go. Now this will actually give us a great demonstration on wiring this to the correct terminal as well, ensuring that we go to the in and not the out. Okay, now the in on this device, as we know from reading the face, is this terminal. So we're going to go to here and we are going to connect our lock washer and nut to secure that in position. And then we can actually connect the out going to our Blue Sea 5025 DC bus bar as well. We will run this over like so. And connect that loosely, or snug rather. And then we will go through and torque 1, 2, 3, 4 connections to spec. And once we do that, the main connections will be complete. Okay, those bolts are torqued and ready to rock. Next thing we're going to do is we're actually going to complete the last 2 connections to our battery protect. In the center of this device is a wire that is labeled GND. Again, we know from our Orion XS that GND is synonymous with the negative cable. So right now, this device only has positive power coming to it, and so in order for it to function, it does need some type of negative connection to complete that circuit and give the actual control board in the device enough a connection in order to complete the circuit so that it will work, right? So what I like to do is actually just remove the terminal block from the device. I will insert my ground wire and go ahead and tighten it up in my hands. So I have a pre-made black ground wire with a ferrule on one end and a lug on the other. And it's actually going to run right over here to the negative side of our Blue Sea fuse block. So we will route that. And then when we have completed this, we will route a communication cable down to the H on this device, which we know is going to let our BMS control it remotely. Okay, ready to rock. Now, we're going to pull the remote port off, and we're going to look down here and make sure we're wiring it to the H and not the L, which is actually going to be the right side. I'm going to grab my pre-made wire here that also has a ferrule and on either end so that we can wire it to our BMS. And we're going to go ahead and connect this guy just like we did the last terminal. Okay, now that we have that wire connected, we will reinsert it there, and we can actually route this cable up to somewhere in this neighborhood where we know that it will ultimately be connected. So we'll just leave that cable there. And if you're wondering why I decided to use a red cable there versus a blue cable up here, there really is no rhyme or reason. You can use any colored cable that you want for these communication cables. A lot of people will use other colors, purple, for example, or yellow, just to signify that it is indeed a communication cable. But it will serve the purpose no matter what color it is. And so we are now finished wiring up our battery protect. Everything is torqued and it is ready. Okay, now that we've completed wiring up our battery protect, we're going to move on to our Multiplus. Okay, so what we're going to do is we're actually going to pop off the bottom cover. I'm going to walk through that process, and then we're going to run our wires from our Links distributor over to our Multiplus. All right, so let's get started. The first thing I want you to notice is how the cover on the Multiplus is actually attached, okay? Some of them have the screws coming straight in the bottom like this. Others now have the screws coming in the face like this. The ones that have the screws coming in the bottom like this can be rather challenging to remove, especially if you mount this in a cabinet and there's not a whole lot of room down here. You may have to grab like a short screwdriver in order to make this happen. But in this particular situation, we can get them off without a whole lot of trouble. There are two of them. Now this should just drop straight down like so. I'm going to grab that, set it right here, and make sure that you do not lose your screws. I actually like to put them back in the hole so that I don't lose them. Now, the first cables that we are going to route to our Multiplus are going to go from here over to here. What you'll notice is that you have a positive side and a negative side, okay, over here. Positive, of course, is red, negative is black. Now my cables are down here. I'm going to snag them, and we're going to hook up the negative first. All right, so we're going to do this just like we did all the other devices. I'm actually going to place this cable right here, just like that, and let it rest. And then we're going to make that attachment first. One thing you're going to notice about working with a 12-volt system is that it requires you to run some pretty big wires at times, specifically 4/0 cable. And it's important to be patient when you're working with 4/0 cable, because it can require you to, just work with that big stiff wire and get it into some tight places. But don't force it, and everything will turn out just fine. So we're going to make sure that our lug has good contact with our negative bus bar back there. We're going to go washer, lock washer, nut, and we're going to get that guy torqued down. Need to swap sockets real fast. And here we go. Need to reset torque back to where we were originally, that 14 Newton meters. And we'll get this torqued. All right, now we're going to move over here, and we're going to make our Multiplus connection. And we are going to put it on this stud here. Now, as I make this connection, I'd like to point out that when I put that cable on the Multiplus, you probably saw the Multiplus rock like this a little bit, okay? And the reason that happened is because it's connected up here on the mounting bracket, but it is not connected down here, okay? So there are two other mounting feet down here, here, and here. And so once I finish doing this negative connection, I'm actually going to go ahead and throw two screws in that, just so that you guys can see that process. Okay, got that one tight. Now we're going to throw those two screws in that we mentioned just a second ago. I'm going to screw those in right here. Got that problem solved. And now we'll run our positive cable from here over to our fused spot, like so. Now, as you guys were watching me install this cable, you probably noticed that it was a bit cumbersome at times, and working with this large 4/0 cable is sometimes a bit of a challenge, right? We mentioned it earlier. I'm just going to mention it one more time. Just be patient, and as you try to work it through some of these tighter areas, just note that it might take a little extra effort and that you do need to be cautious of what you're doing. You don't want to break off one of these studs or cause any other damage trying to force it. So be patient. Now I'm going to go ahead and attach this connection point over here. So washer, lock washer, nut. All right, that's one connection made on the Multiplus itself. Now we're going to move over to this connection and we're going to connect it to our fuse. One thing I do want you to note is that there is a bit of an interference on the mega fuse and where the lug come together. And what's ultimately going to happen is this lug and this fuse are going to come together. And as you tighten them together, the fuse is going to deform such that it actually makes contact with the lug. Newer versions of the mega fuse, which Victron is now selling, have a recess that allows you to use these mega fuses with these larger lugs. But in this particular example, it probably isn't going to look very awesome. And we do get a lot of questions about it, but it will be functional for this demonstration. Now, I'm going to go ahead and connect these 2 points, top and bottom, washer, lock washer, nut. Now, all of our DC connections have now been made between our system, our Lynx distributor, and our Multiplus inverter. So we now have everything that we need there done on the DC side. Now it's time to move to the AC side. And in order for us to wire the AC side, we've got to talk about what our circuit protection looks like on the input as well as the output. So this unit is actually an inverter charger. So it will take AC power and convert it to DC power. In doing that, it will also allow you to take AC power and convert it to DC power in the form that it will actually charge your batteries, okay? So right here you see 12, 3000, 120. This is actually a 120 amp DC charger. So you can feed it 120 volts of residential input power from your shore power input, and it will convert that to DC and charge your battery banks at 120 amps. All right. So down here, you see this small gray enclosure. This is actually a Midnight Solar baby box. There are many different types of enclosures like this. Inside this box, there is a small DIN rail in which we like to mount CBI breakers. CBI is just a brand of breaker that we found that works for this application. And what we've done here is we've actually installed two 15 amp breakers that allow us to give ourselves some circuit protection on the input, as well as we will also use this same box on the output. Now for training, we're able to do this in one box with only two breakers. In the real world, you're probably going to have your AC out running to some other type of AC distribution block or a independent enclosure, like a whole separate baby box designed specifically for your AC outputs in your system. So here we have one for input and one for output. And we have simply used an old extension cord to give us the functionality that we need. All right, and so over here, this is our output and this is our input. Okay, so we will trace the input, and it is actually this right side, all right, or the lower side of our box. And then this over here is actually our output. Okay, so we will wire those wires to the AC out, and we will wire the other side to the AC in on our Multiplus. If you look up here in the Multiplus, and if you also you can also reference the syllabus or the manual for the Multiplus, you will see how these are laid out. Okay, over here you have your AC out 1, you have AC out 2. AC out 2 is over here, and your AC in is over here on the far right. Depending on which inverter charger you're using, some of those things may be in different locations, so keep that in mind. On each location, you have an L, you have an N, and you have a PE, okay? L is your hot wire, PE is your ground, and N is your neutral, okay? So L stands for line in this instance. And so we will wire them in that way. So L will be our black wire, PE, our ground, will be our green wire, and N will be our neutral or our white wire, okay? So what I'm going to do is I'm going to go ahead and wire up each one of these and show you guys some of the things that you need to be aware of there. All right, I'm just going to make sure that I have these in the correct orientation. So that side is our input. And what you're going to notice about this particular inverter charger is that it has spring terminals. And what do I mean by spring terminals? It actually has these green blocks that you have to stick the wire into until it stops and actually grabs that wire. In order to remove the wire, it has another spot that you need to put a small screwdriver or something to release that spring terminal to pull these back out if you need to do that. But the best way that I found to install wires into these spring blocks is to, one, use very long ferrules, right? You will notice that each of these wires has a 19 millimeter ferrule on it. And what I like to do is I like to feed it through the wire reliefs here. Okay, so you will need to cut these white wire reliefs here. They simply prevent your wires from getting cut. So you will feed your wire up through here. Okay, and you will position it in such a way that you have plenty of slack ready to insert into the spring terminal. All right, and inside the Multiplus, they also provide you these clamps so that you can give yourself something to grab the wire once you complete this process. And what I'm going to do is I'm going to choose the black wire first. I'm going to make sure that I'm lined up with the input, and I'm simply going to press it into the large circular hole. Do not press these into the smaller square hole. That is your spring release. Okay, so I'm going to press that in there, and normally I can get a pretty good engagement from doing that. If you feel like you need to push it in there a little further, I like to grab a standard set of needle nose pliers, grab the wire just below the ferrule, and just make sure that you've got full engagement, okay? So it just went in slightly further, and I feel very confident that it's in there nice and secure. I like to give it a tug just to make sure it's not going to come out or that I have a bad crimp on my ferrule. The next wire in line is my ground wire. I'm going to feed it into position, and then I'm going to press it in as far as I can. I'm then going to use my needle nose pliers and get it seated all the way in position. I'm going to do the same with my neutral, and then I'm going to move over to my AC out. This wire is going into AC out 1. What you need to know about AC out 1 is that AC out 1 works on DC power, so as when it's inverting, as well as when it's plugged into shore power. So it will do a transfer for you, or it will work off your batteries. Okay, now that I have AC in and AC out wired, I'm going to cover just a few more things that you should know about wiring this up and kind of how it functions. So we have AC in over here. Again, we have line, PE, which is your ground, and N, which is your neutral, okay? And they are clearly labeled, and you do need to make sure those wires are in the correct location before you power this on. That is one thing that could cause you quite a bit of heartache, is if you were to get line and neutral mixed up, okay? You do not want to wire this up in reverse polarity. The other thing I'll note is that you do want to snug up your wire clamps that they've offered you in here, okay? So you'll grab your socket and you'll snug those down so that they grab that wire. In the event that you did for some reason not get a great insertion on that spring clamp, at least that wire is not going to go anywhere. Then you really want to give these a snug, right? You want to give these a tug rather, not a snug, and just make sure that they're not going to come out of those spring terminals. Make sure you've got good engagement. And then the last thing I want to cover is we get a lot of questions about what is AC2 out, right? So why is there a second AC out on this unit? That out terminal is there so that you can use it on straight pass-through. So let's say you had a big device in your system that you only wanted it to operate when you were plugged into shore power. You could wire it directly to AC out 2, and it would only work when you're on shore power. So AC out 1 is going to work whether you're on battery or shore power. AC out 2 is only going to work when you are plugged into shore power. So just keep that in mind. Typically, the systems that we see are always wired to AC out 1, and then very rarely we'll see AC out 2 used as well. Now, beyond that, the only other connection that is visible right now is this ground lug right here. You will run that to your chassis ground. Okay, so in a system like this, if it's a mobile application, you could run that from here over to here, or you could run that, simply go from here down and back over to here, because you have a solid ground connection from here back over to your Lynx distributor. And ultimately, you're going to ground this Lynx distributor and your system as a whole off of this lug down to your chassis ground. Okay, so that is why they offer you this fifth lug here, or this fifth spot rather, is so that you can connect your chassis ground here and run it to the location where you decide to put it. Okay, that pretty much covers all of the wiring on our Multiplus. I'm going to jump back down here to this enclosure here and just show you guys that the circuit protection is used on the black or your line wire. Okay, the hot wire is going to go through circuit protection. Your ground and your neutral, you can run those to just another terminal block, and they would be more of a straight pass-through. So you'll notice that the green is going into one side and then just coming right back out without going through any type of circuit protection. So we now have all those connections made, and we can actually put this cover back on, which I will do now. All right, now that I have that enclosure back on that box, I'm just going to make sure those breakers are set in the off position and clearly labeled as well, right? So one says in, that's our shore power in, and then out, of course, is our AC out, which is actually going to feed the AC outlets in our coach or our AC panel, right? Okay, the next thing we're going to do is we're actually going to finish wiring all of our communication cables to our Lynx Smart BMS. So we're going to get started on that, and I'm going to show you how that comes together. The first thing I'm going to do is I'm going to remove this fuse block cover here so that you guys can see all the connections that are going to be made. And then we're actually going to be walking through what each of these pins down here do. You guys currently cannot see what is labeled here, so I'm going to tell you what those labels are, and we can reference them as well so that you guys can see them. But what you have down here is you have pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. All right, you have 11 pins to work with. Pin number 1 is simply going to send power to another device. All right, so it is simply going to send positive voltage to another device anytime that this device is connected to DC power. All right, so what that looks like is we use pin 1 to run down here to a fuse block. This is a Blue Sea 5045. So we're going to use pin 1 to supply power to this positive fuse block. The next thing we're going to do is we're going to use pin 2 to supply negative power to another device. In this particular instance, we're actually going to use pin 2 to supply the negative power required to run our servo. All right, now what we're going to do is we're actually going to use pin 1 and pin 2 to provide power to our servo. So in your servo box, you will receive a servo power cord, and it will come with a small connector like this, and it will have just 2 cables coming off of it. One will be red and one will be striped red and black. You'll notice that both of those have a ferrule on them, but we've modified this particular power cable to have a small heat shrink lug on one end and a regular ferrule on the other. And we've also adjusted the length a bit, which you will probably also need to do. The first thing I'm going to do, I'm going to plug this in the bottom of the servo, and then we'll route our wires to their correct locations over here. What we're going to do is we're going to take our negative cable, and we are going to route it up to pin 2, right up here. There you go. Inserted into pin 2. And we will then tighten that down. And we are going to take the positive cable, and we are going to actually route it to one of our fused locations on the Blue Sea 5045 fuse block. So as I do this, the entire point of this fuse block is to provide us a location where we can fuse all of these connections. Because we know that if we don't have a fuse in a connection, the wire is the fuse, right? And we do not want that anywhere in our system. Now that we've made that connection, I'll take just a second to show you guys what type of fuse holder this is and what type of fuse that we're using, and also how do you size a fuse for a wire this small. So this is a standard ST fuse, also known as an ATC fuse, and these are available in some very small sizes. This particular fuse is actually a 5 amp fuse, which is certainly oversized for this size wire. We would typically run a fuse something in the neighborhood of 1 to 1.5 amps for a wire of this size, but you would actually size the fuse and the wire in the exact same way that you would as any of these other connections. So just because you're using a different type of fuse and using really small wire, you still want to go and you want to size this fuse for the specific application. So I'm actually going to move this fuse over to this spot, and we are going to carry on. Just going to set this fuse to the side for now. Actually, we probably will not use that fuse in general. So now we have a 2 amp connection here powering our servo. So our servo now has both positive and negative connections, negative coming from pin 2, positive coming from this fuse block. Right. Okay, the next thing we need to do is we actually need to get power to the fuse block itself. And in order to do that, we're going to run power off of pin 1 down to this lug here that gives power to this entire block. So we're going to do that now. And we're simply going to route this wire down and back up to pin 1. All right, that connection is now complete. The next thing that we want to do is we actually want to provide power to pin 3 and pin 5. Pin 3, as you can see here, is ATC. So pin 3 and 4 are part of the allow to charge system, right? So what that does is we're going to send power up to ATC, and then when the BMS wants to allow other chargers in the system to charge, it's going to send that voltage over to pin 4, and that's going to send that signal up to, let's say, the remote port on a charging device. So we're going to get power up to pin 3. When it wants something to charge, it's going to send that power over to pin 4. Pin 4 is going to send that voltage up to the high side of this remote port and tell this guy to work. All right, so let's go ahead and do that and make that connection. We'll use one of these short pre-made wires here for that. Okay, pin 3 connection is now complete. We're going to now route pin 4. So pin 4 is actually a wire that we ran earlier. This is going to be any cables that are connected to a charger that we want to control via the remote port. Now you're probably asking yourself at this point, but Dan, what if I have more than one charger? Well, the answer to that is actually pretty easy. What you could do is you could take this cable and you could daisy chain it, right? So you could actually run this into, let's say, a WAGO connector, or they do make, two-sided lugs that you could run 2 wires into one ferrule for that connection. But the easiest thing I found to do is just grab a WAGO connector and simply daisy chain wires to the remote ports on all the chargers that you want to control in the system. Okay, but in this application, we only have one. And so we're going to simply route this wire up to pin number 4, and we're going to tighten it down. All right, excellent. Now we are moving on to ATD. And we remember from earlier that ATD stands for allow to discharge. The first thing we need to do is we need to put power on pin 5 so that it can use that power to tell downstream devices like our battery protect when to allow discharge and when to turn off. So here we go. Okay, connection made to pin 5. Now we need to make our last connection that we're going to make on this particular example, which is going to be pin 6, which is the second port on the ATD circuit. We're going to insert that. Now, you have completed all of your wiring for this particular terminal block. Now, the last thing I want to cover about this terminal strip down here is that the last 2 pins are used as a remote. And so where you have this jumper wire, if you were to remove that jumper and wire a switch to this location, what that allows you to do is it actually allows you to control the contactor in this BMS. So you can actually open or close the contactor with that remote port. So let's say that you wanted to run a switch outside of your enclosure somewhere that would actually kill DC power downstream of this device. You can do that. A lot of people like to wire one of those fancy blue light up switches to these 2 ports here, and that is certainly an option. In addition to that, we also like to run a physical disconnect switch, but some people don't use the physical disconnect switch and do rely on the contactor as their actual main shutoff. So that is something to keep in mind. And with that being said, we're now going to actually move on to the other ports on the bottom of your BMS. We've only got a couple more to go. Behind this terminal strip, there are actually 2 RJ45 ports. RJ45 ports coincide with Cat5 or Cat6 cables, like this pretty blue cable here. And in this particular setup, this device uses VE-CAN. Now, VE-CAN is simply Victron's nomenclature for the protocol that's used for communication across those 2 ports. Now, the thing you need to know about VE-CAN is that it does require termination at the first and last device in the circuit. So this device operates on VE-CAN, therefore it will require a terminator if it is the first or last device in a circuit. In this particular example, we have this device that operates with VE-CAN, and then you have your servo that has 2 VE-CAN ports. So we're actually going to run an RJ45 from one of the ports here over to one of the VE-CAN ports on your servo, and then we're going to insert the terminators as well. And so I'm going to go ahead and do that now. All right, now that we have our RJ45 cable plugged in there, I will point out where I connected it on the servo. There are 1, 2, 3, 4, 5, 6 places where you can plug in an RJ45 on the back side of the servo. There's also a LAN port up here in the front. You're going to plug it into one of the 2 middle ports that are actually labeled VE-CAN. Once you have your cable plugged in, you're going to grab one of your 2 terminators that also come with this device. A terminator simply looks like this, right? It's just a RJ45 connection with a dead end on it. I'm going to plug one in here, and I'm going to plug the other in the bottom of my BMS in the second BMS port. It's hard to see from here, but it is there. And then you are done with your RJ45 connections. The other thing that I want to point out while we are connecting our first RJ45 cable is that you will notice I used this nice, pretty blue cable provided by Victron. This is a straight pass-through cable, all right? And we have found that Victron cables do work very, very well and that we have a very low failure rate on them. It is highly advisable to use pretty blue Victron cables, but if you are going to purchase your own cable, just make sure that it is a straight pass-through RJ45 Cat5 cable. Okay, so that connection is now made, and the very last connection that we need to make is our M8 connection. Now, you probably can't see that very well from here, but you have a male and a female end that connect to those cables that we inserted into our battery cables earlier, our battery M8 cables. So I'm going to snag the M8 cables connected to our battery down here, and we're going to go ahead and make those 2 connections. Now, I have the cables, and I've got, just like before, we have our male and our female, and we're going to match those up to the coinciding ports on the bottom of our BMS. Take your time when you're making these M8 connections. You want to ensure that you don't cross-thread either one or break any of your pins. All right, the next thing that we need to do is we need to run our other communication cables in the system. We only have a few left, and the one that we're going to do now is our RJ45 connection from our Multiplus to our servo. Now, the Multiplus is actually a VE bus device. So unlike VE CAN, you do not have to use the terminators for this connection. So we're simply going to run an RJ45 from here, which is one of the two VE bus connections, over to one of the RJ45 ports on our Multiplus. Do not plug this cable into this front LAN port or it will not work, okay? So I'm going to snag this cable and we're going to route it, and then we'll be done with our communication connection from there to there. Now again, you'll notice I'm using a pretty blue Victron cable. I'm going to go ahead and insert this into here. Now, it's helpful to route this cable up through one of these center wire glands, but it doesn't really matter which one that you go in through. And then on this particular Multiplus, you'll actually route this cable up and then plug it straight into one of the ports that are located here. We routinely get questions from customers, does it matter which port I plug it into on a Multiplus? There are two ports on the Multiplus, and the answer is no. VE bus, it doesn't matter which one of the ports that you use. So plug it into whichever one you would like to plug it into, and it will work just fine. I'm going to tuck some of this wire up into this wire tray so that we can make it look nice and pretty here in a few minutes. And then from here, we are actually moving on to the final stages of our setup, which is connecting a few other ancillary devices. I'm actually going to wire up this light just so that we can see it come on when we do commission the system. And then I'm also going to go ahead and connect my Touch 70 to my servo. I'm going to spend just a few minutes talking about the Touch 70's connection to the servo so that you guys understand some of the limitations there. When you receive a Touch 70, it will have two cables that come out the back of it. Those cables look like this. So you have an HDMI with a small pigtail that is a USB. The USB is actually providing power to the screen. The limitations of this setup are that you only have this much cable between your Touch 70 and your servo. So let's say you wanted to put your Touch 70 30 feet away from your servo, you have to solve this problem. What we've seen is that you can extend this HDMI no problem, but that the amount of voltage loss you see when plugging in this USB and using a 30-foot extender causes the screen to either be dim or to flicker or not function at all. So if you plan to extend this cable using an HDMI extension and a power extension, basically a USB extension, do the HDMI and go ahead and plug it back to here. But try to grab your USB power closer to the device so that you're not trying to power it with a 30-foot extension on it and experiencing all that voltage loss. But for this application, we're going to go ahead and we're going to plug our HDMI into the HDMI port right here. And then we're going to plug our USB into this first port here, which on this particular version of the Servo GX has a little power symbol. It's designed for that function. And then from there, the Touch 70 is ready to go. That's all you need to do to plug it up and have it ready to work. All right, so the last thing that we need to do before we commission our system is put the right fuses in the right locations, specifically down here in this fuse block and in our 5045 fuse blocks. I'm going to do that now. So I snagged a couple of 1 amp fuses, and I'm going to insert one here and one here. And then I'm going to install that cover. The next thing I'm going to do is insert a fuse here, I'm actually going to move this fuse up to this location. That will work well for that. And then we are going to apply that cover. All right, we have that cover installed. And the next thing that we're going to do is we're actually just going to do a general safety check. And what you want to do here is you want to just start from one side and move to the other and check your connections. Make sure that you actually torqued everything as you were supposed to. Make sure that you did not wire your AC wires in reverse polarity. Make sure that everything is grounded as it should be. And just do a general safety check. Okay. And then once we do that, we'll be ready to actually hook up our battery to our positive and negative connections and commission the system. So what I like to do when I do my general safety checks is I like to go through and just make sure that everything was torqued as it should be. A special note on that is, one of the best practices that you could do that we haven't done here, but that I would highly recommend that you do, is actually have a marker with you, right? And when you go to torque a connection, give yourself some visual indication that you actually torqued it, right? It could be simple as a mark on the cover that says, all right, it was torqued. I've also seen others actually color the end of the stud, right? And it helps to have a different color, right? You could do black or you could do blue, but grab a paint marker or something like that and give yourself some visual indication that the torque setting was done properly and that that bolt is torqued. So as soon as you torque it, mark it, and then move to the next one, right? That is a great best practice. The other thing I like to do is, literally just make sure that I don't feel anything that is loose. Of course, those connections should be loose, right? Just go through and check these things. Make sure that none of your connections look out of place. Also, give it a visual once over to make sure that negative is where it should be and positive is where it should be, right? You don't want to mix these connections up. You don't want to mix these connections up or have positive coming in one side, negative the other. So just run through it all. Make sure everything looks good. Make sure that everything is torqued. Make sure that your AC connections are good. And then you are good to proceed to actual commissioning and setting everything up how you would want it. The last step that you've got to cover, though, is you do want to put these covers back on to ensure that you don't have exposed AC and DC connections as you commission your system. So I'm going to snap these covers back on. Okay, now that your covers are back on your Smart BMS, your Links Distributor, and your Multiplus, the last and final thing we're going to do before we go to commissioning is we are going to clean up our system a little bit so that it looks professional. All right, so we're going to pop these wire covers on. And if you're not planning on using wire channel in your build, I strongly recommend that you consider it. It does make everything look much cleaner. Okay, so still not as professional as we would like it to be when all is said and done. But at this point, this is where I would feel comfortable actually commissioning the system. After I commission the system and I make sure everything is functioning as I would want it to, I would then come through here and I would start to clean up some of these other connections just to make them look even cleaner, right? So throw a zip tie right there, throw a couple zip ties in here, hide some of this excess wire down in our wire tray. And when it's all said and done, you will have a very clean and professional looking build, right? In addition to, you could zip tie up some of these cables, route some of these cables slightly different, and when all is said and done, you would have something that you could be very proud of. Now, we've reached a very exciting point in our system build where we can actually hook up our battery. So I'm actually going to do that now. I'm actually going to have to remove this cover once again and connect our positive connection here, and then we will connect our negative connection. So pop this guy off. And we will remove this nut and lock washer. And we'll bring our positive cable up and have it connect here. Now, before I bring my positive cable up and connect it here, I will point out that you do not see any fuse protection here. It is critical that you have some type of fuse protection between your battery and the rest of your DC system. Typically, you're going to want to use a class T fuse if you're running a lithium iron phosphate battery. So in this particular demonstration, we are using a small terminal fuse connected to the positive of our battery so that we have some type of fusing for this training and demonstration. But you guys cannot see it here, but it is critical that you do have a fuse connected to the positive side of your connection prior to coming to your master disconnect. Okay, so fuse in here. All right. Here we go. All right, we're going to torque that down. Okay, positive connection is complete. Now we will move over to our negative connection. Our negative connection is going to happen here, and what you will discover is that this device does not come with a way to make this connection. So if you do not buy a kit like our Lynx distributor connection kit, you will need to purchase a either 5/16 or M8 bolt that you can use to connect your lug to this spot. You need a bolt that is at least 1 1/8 long, a lock washer, 2 washers, and a nut. All right. Highly recommend stainless for this application, but you will simply take your bolt and your washer and you will connect this connection. Okay, now we're going to make our negative connection. We're simply going to take our cable and route it over to this point. I'm going to insert my bolt and then go washer, lock washer, and nut. All right, now that we've got that set in position and snug, we will go ahead and torque it down. I'm going to drop this back down to our torque spec for that size bolt. Okay, now positive connection is complete, negative connection is complete. Now we need to put our switch cover back on. You guys will notice why we like using this switch so much. It makes wiring these connections way easier than the type where you actually have to take the switch off, wire it, and then screw it back to the board. But this switch makes life far easier than that. And you simply turn those 2 gray screws to lock it back in position. And at this point, we'll do one final once-over of all our connections, right? The connections that we just made, make sure they're tight, make sure we've got good crimps, check the connections on our batteries, and then we're ready to commission. Commissioning simply means turn that switch to on and watch the pretty blue lights come on. So, the first things that you'll notice, we have DC power because our light came on. The very first action I'm going to take is actually to remove this fuse to turn this light off so that it's not blinding us. DC power is on. You heard a very loud clunk when the system came on, and that tells us that our contactor actually closed and allowed power to move downstream. We also see a green light here, which is a great indication. You see a flashing blue light here and a solid green status light on our BMS, which means everything is functioning as normal. Now, it does take maybe like a minute or maybe slightly more than a minute for your servo to power up. When it is done powering up, you will see your Touch 70 come online. This particular setup has been used in many trainings, so our battery's sitting at pretty low voltage. and our servo is currently not connected to Wi-Fi or Bluetooth, which is why you have a flashing blue light and a flashing orange light. No big deal. A few other things that you're going to notice is that you do have a blue flashing light up here on your Orion. You also will find a blue flashing light on your MPPT. That indicates that they are at least receiving power and that you can probably see them in Victron Connect so that you can move on to programming. You'll also see a big green light on your inverter. Now, the inverter came on the instant that we commissioned the system because the switch was already on. Typically, when you commission your system, right, the inverter switch is actually going to be in the off position. The inverter switch is down here on this particular Multiplus. And what you're going to find is that it is right here. It's kind of hard to find, but there's actually 3 positions, okay? There's a 1, there's a 0, and there's a 2. 1 is inverter and charger. 0 means it's off. And then if you were to press it all the way backwards, that would be charger only. So it would only function in the charger mode. But when we commissioned our system, that switch was already on, and so the inverter fired right up and it is functioning normally. And you'll see a big green inverter on light that's indicating that everything is working normally here. Now, with all of that being completed, the next phase in this project is to program each individual component. I'm going to quickly run through the tools that you would need to program each component, and then I want you to reference the videos on our resource page on seqengineering.com as to how you would actually program each component in this system. Not only could you reference each individual video that we will soon post, you also could reference the back half of this syllabus, which actually walks you through with screenshots how to program every component in this system. Okay, the hard part is over. You have fully commissioned your system, nothing caught on fire, we don't see any smoke, and now you're ready to move to programming. I'm going to very briefly walk you through what tools you would need in order to program each of the devices up here, and just a few of the steps that you might want to take. If you need further detail beyond what I cover here, I would encourage you to either walk through the syllabus or to jump over to the resource page on our website, where we're going to be posting videos on how to program each of these components as well as other Victron components. So, Orion XS. You're going to program your Orion XS over Bluetooth on your phone using your Victron Connect app. The same is true for your MPPT. You're going to use Bluetooth. You're going to program that on your phone. Your BMS, same. You're going to walk through the settings in Victron Connect over Bluetooth on your phone. Same goes for your battery protect. You're actually going to look at it on your phone, set the parameters. It's very easy to program it on your phone over Bluetooth. Your battery actually doesn't require any programming, but if you wanted to see it and what's happening with it, or update the firmware, you can do that over your phone, okay? The newer version of the batteries, the NGs, you will be able to do a little bit more with, but for the smart batteries, you will simply update firmware on your phone and then look at parameters if you want to do that. The servo, you will be able to see the servo in Victron Connect, and you'll be able to connect it to Wi-Fi. Once you connect it to Wi-Fi, you can also then connect it to your VRM account. We're not going to cover a whole lot on VRM right now, but do know that you can do that in the app. And beyond that, you would do most of the programming on your Touch 70, or you could connect to that device remotely to program it. I highly advise programming it and setting up all your parameters on your Touch 70 after you use the Victron Connect app to simply get it on Wi-Fi. Okay? Multiplus. The Multiplus is the only device that you're going to need another device to program. All right, so you would actually need an MK3. An MK3 is just a small box with a USB cable coming off of it that you would use to hook up to your Multiplus. All this is laid out in the syllabus. All this is laid out in our upcoming video on how to program a Multiplus, but you would need a separate device and a laptop in order to program the Multiplus. If you need your Multiplus program before you get it, simply ask your distributor, hopefully that's us, and we will program it for you. That covers everything you need to know about at least what device you would want to use in order to program all these components. Now, you've just watched us completely build this system, and you might be wondering, is this system for me? The beauty of this system and the way that we designed this training and this demonstration is that you can pretty much adapt this system to any need that you have. right? We could go and we could get a larger inverter, we could get different size chargers, but as you look at this system, all of the foundational pieces, all the things that you would need to build, let's say an RV system, an off-grid cabin system, or even something much larger, right? Something that you would use in an industrial scale. You could basically take this recipe and scale it to meet any need that you have. If you're intrigued by what you saw here today, Sequence Engineering is here to provide you with the equipment and the resources you need in order to solve the problems that you have in front of you. Thanks for watching this video. If you need any more help, feel free to reach out.